As you may have noticed, in the past few years, high-frequency ham radio beam antennas have not only become more complex, but also far more narrow in beam width. Some claim to be as narrow as 4 to 5 degrees, with a front-to-back ratio of 30 dB or more. This in turn requires a more accurate rotor and pointing device, one that can swing a very heavy multiband Yagi from east to west in record-setting time, yet be able to stop on a dime without permitting any antenna motion, even in gale force winds. Well, down under in windy Perth, Australia, a company known as Twist-A-Tenna has been doing research aimed at producing a new antenna pointing system, one that not only minimizes power consumption, but is also capable of automatically synchronizing up to 360 cardinal grammeters for exact antenna orientation. And while it's taken a bit of time to contort, now it's here. Meet the maker of the Twist-A-Tenna Model 1-4-2012 contest and DX rotor system.
To be quite candid, the only really new principle involved is that instead of rotational power being generated by the relative motion of conductors and fluxes, in the turbo-entabulator contest and DX rotor system, motion is produced by the medial interaction of magneto-reluctance and capacitive durectance.
During the initial design phase, the concept was to use a base plate of free famulated amulite surmounted by a malleable logarithmic casing attached in such a way that the two spurving bearings ran in a direct line with the parametric fan. This meant offsetting the rotor from the tower by 36 to 40 inches. Not a good idea for installation in small city lots in crowded urban areas. Now, however, after several years of research and development, the final design stage consists of 6 hydroscopic Marzul vanes fitted to an amberfescent lunar wane shaft made of titanium alloy to prevent any side fumbling, and there's no need to offset it from the tower centerline. The main traction winding is of the normal Lotus ortotoid type placed in a panoramic semi-bulloid slot of the stator. Every 7th conductor is connected by a non-reversible trimmy pipe to the differential girdle spring on the up end of the grammeters. Moreover, whenever fluorescent square motion is required, it may also be employed in conjunction with the drawn reciprocation dingle arm to reduce sinusoidal depleneration. In other words, when the rotor braking system is engaged, the antenna is locked in position and will not move unless you, or possibly your pet cat, hit the control box to move it. The Twist-A-Tenna Model 1-4-2012 turbo-entabulator antenna pointing system has now reached a high level of development and is being successfully used in the operation of the fully functional automated DXCC logging station of Milford Turins in the United Kingdom. Best of all, the entabulator antenna pointing system is now available for less than $19.99 per tower installation kit wherever Twist-A-Tenna products are sold. Now here's Gordo to explain in layman's terms exactly how the antenna system works.